What is the direction of the magnetic field there? Is it? Let's see. Can we use these answers? No, I'll give you some new options. So, is it left, right, up? Negative particle moving to the right, the force pulls us down. All right, stop in 10 seconds, 1 minute. Just a few more seconds. Okay, awesome. B is right. B is to the left. My force is going to be down like that. That means my magnetic field would point out of the page, except it's a negative particle, so it's into the page. So if you do your right hand normally, you get E, but then you realize it's a negative particle, and so you flip it to B. Okay? Listen, there are some homework problems on this, and I would, if you haven't done so well on these, I know there are a handful of you that haven't done so well, look back at this. You can come to my office too. I can give you a little primer. We can work through some of these problems. But you'll see several of these in the multiple choice part of your exam. Probably not free response, but maybe, but probably not. Also, if you just need extra practice, if you go to the old exams in the multiple choice, usually exam 2 or 3, you'll see some. But also, if you want even more, you can go to the Physics 102 exams, look at theirs. Just with the Physics 102, make sure that you understand that if you're practicing from these exams, that you're only going to get sort of the conceptual questions from their exams. So they have their sort of your free response problems, they have peppered throughout multiple choice. Okay, so if you do go to those 102 exams, those can be valuable for you to practice from. Just be aware that there are problems you won't have. Okay? Let's see. What do y'all need help with right now? What do y'all want to go through? Number 16, and which exam is it? Oh, that's in our book, okay. Okay, yeah, this is a good one. So this is an example of the combination circuit that you might have. The first thing that you'll need to do is just to find the equivalent resistance. I know it doesn't ask for it here, but you really need to find the equivalent resistance. So you would first combine these two resistors. They would be 1 plus 2 is 3. And then you would have 3, 6, and 2. So I'd have 1 over 3 plus 1 over 6 plus 1 over 2. That's, what's that, 4 twelfths plus 2 twelfths plus 6 twelfths, that's 12 twelfths, that's 1. So 3, 6, and 2 in parallel is 1. And then I have a 2 and a 1. 2 ohms, 1 ohm, and the equivalent of that is going to be 3 ohms. And I'm looking for the voltage across R3, so the voltage across this resistor, the total current in the circuit, that's this current, and the current through R2, which is this resistor. I want to know I through that resistor. Okay, the total current, you should be able to tell me right away, what is B, the total current? It's going to be 3 amps, because the total current is this current, I is equal to V over R.
That's 9 volts over 3 ohms. That's equal to 3 amps. So the total current is 3 amps. And then if I have 3 amps going through that circuit, that means I have 3 amps here. So I have a current of 3 amps here and a current of 3 amps here, because resistors in series have the same current. And whatever current is going through that circuit is also going through these two resistors. So if I have 3 amps here, 3 times 2, I have 6 volts. 3 times 1, I have 3 volts. That makes sense. 6 plus 3 volts gives me 9 volts. So I have 6 volts and 3 volts here and here. That means I have 6 volts here, and I have 3 volts here. I have 3 volts across both of these. They're going to split it, and I have 3 volts here. So let's see, I want to know the voltage across R3. We'll come back to that. What is the current through R2? Here, if I know the resistance and I know the voltage, I is going to be V over R. That's from Ohm's law. That's going to be 3 over 6, or 0.5 amps. So down here for part C, it's going to be 0.5 amps. And then the voltage across R3 is a little trickier. But you know that the voltages across these two resistors have to add up to equal what?
3.
They have to add up to equal to 3. And I know that one voltage is going to be twice that of the other voltage, because my resistors are, one is twice that of the other. Which is going to have the higher voltage, the 1 ohm or the 2 ohm resistor? The 2 ohm, right. Remember, these are different from capacitors. Y'all are thinking capacitors. With capacitors, a smaller capacitor has a bigger voltage. Be careful with resistors, the smaller resistor has a smaller voltage. All right, so I know then I'm going to have 1 volt and 2 volts here and here. So the voltage across R3 is going to be 1 volt. Sort of the harder way to get to that is that I know I have 3 volts here across 3 ohms of equivalent. That means I have a current equal to 1 amp. So going through here, I have 1 amp of current. And if I have 1 amp of current across a 1 ohm or through a 1 ohm resistor, that's going to be a potential of 1 volt. 1 amp of current through a 2 ohm resistor is going to be a potential of 2 volts. All right? You will have a circuit like that. And they do work very similarly to our capacitor circuits, but they're a little bit different because the rules are a little bit different for capacitors and resistors. You have a homework question like this too, and in some of the older exams you have some as well. Desiree, that help a little? There are lots of steps that go into this, as you can see, and you sort of have to be able to work those resistors a lot as you go through them. You sort of have to see it as you go along. Okay? What else, y'all? 15? We don't have any combination circuits? No, that was a combination circuit. Yeah. This one right here is combination circuit. All right, let's just let's look at this multi-loop circuit. I think most of you have these down, but you'll definitely have it. So just, if you think you got it, just sort of use this as an opportunity to convince yourself that you do. Okay, so here, I tell you where I1, I2, and I3 are, but I don't give you directions for them. So the first step is just to find the directions, or just to assign directions. I'm just going to say I1 is down, I2 is up, and I3 is down. No reason, I just picked those randomly. It may or may not be right, I don't know. Okay, so then I write my equations. I'll take the left loop, the right loop, and the junction rule. But you can really write any of the equations, but left loop, right loop, and junction rule are probably best here. Let's see, would it matter if you did the left and big loops? No, it doesn't really matter which equations you write, because you're always going to get the simple equation coming up. Yeah. So let's do the left loop, right loop, and the junction rule. So the left loop, I'm going to say start right here, and I'll travel in this direction with the current initially. I'll have plus 2 volts, minus 2 I1. It's negative because I'm going with the current, minus 4, minus 2 I2. That's equal to 0. Now let's do the right loop. I'm going to let you do this on your own, but let's do the right loop together, but we'll say start here and go in this direction. So starting at this junction and going in this direction, write the equation for the right loop. I'll give you about 20 seconds head start. All right, so plus or minus 8? Minus. Minus 8 volts. It's negative because I'm going from big to little, from high to low. If I ever go from high to low potential, I get a negative value for my potential, my change in potential. And then here, plus or minus 2I2? It is plus, good. Plus 2I2, because I'm going against the current. And then plus 4. And then that's equal to 0. And then I write my junction rule. Pick any junction, doesn't really matter. I'm going to pick this junction, but you'll get the same one if you pick the lower junction. Go ahead and write that junction rule. I'll give you about 10 seconds. I'll write it up there. Remember, incoming currents equal outgoing currents. Incoming is what? I2 is right. That's right. Incoming is I2. That's equal to I1 plus I3. All right, if you get the equations right, you're going to get many of the points, okay? And then I want you to solve them. You can either solve them by substitution or by that row reduction or Gaussian elimination. I'm going to just do it by substitution. These are pretty simple because notice my right equation only has one variable, so I just solve it for I2. So I2 is negative 4. I2 is equal to 2 amps. I just solve this equation for I2. 2 amps. We chose, it comes out positive, so that means it's up. I plug in this here, and I solve for I1. So I get 2 minus 2I1 minus 4 minus 4 equals 0. I just plugged in that 2 amp for I2.
You had gotten negative, so you plug in the negative.
Yes, I was about to say that. So if you got this to be negative here, negative 2, you would put negative 2 here. And you could have gotten negative, right? If I'd chosen this direction downward, I would have gotten a negative 2. So you never really know if you're going to get negative or not. But remember, if this was negative, you would put that negative here. Okay? You might want to make a little note about that if you're not certain of that. But if it's negative, you carry that negative through all your other calculations. Okay, so it's negative 8, negative 6, I1, I get negative 3, is that right? Am I doing that right? Yeah, so negative 3 is I1. That means I have 3 amps. We chose it down. That means it's up. And now we know I1 and I2. And so we just plug those into the junction rule. We get 2 amps equals negative 3 amps. Notice I keep the negative, plus I3. I3 equals 5 amps. And that is going to be down because it came out positive. 3, 2, and 5, up, up, down. Yours will be very similar to that. You'll just have different values for the resistors. But a similar distribution of resistors. I mean,
you might have a branch with no resistor instead of being on the right or on the left, or I might even flip it so it's vertical instead of horizontal, but it'll be pretty much the same. Is that a question? No. You'll definitely have one of those. Make sure that you can do them. It's not going to be a small portion of the test. It'll be 15 or 20 points. So hopefully that's a quick 20 points that you can. Yeah. Okay. What else, y'all? Cross product, right hand rule, household circuits, RC circuits. I'm sure you can do the exponential. 18? Okay, good. Okay, this is a good indicator of what you'll see, something like this. Simple RC circuit, they're in series, a resistor or capacitor, and a battery. Here I want to know what is the charge on the capacitor after 10 seconds. You would go to your equation sheet and you would find that for charging capacitors, that Q as a function of T is equal to our maximum Q times 1 minus e to the minus T over RC. Let me show you on our equation sheet right quick. I know we're running short on time, but let me show you this just so you're aware of it. Okay, it doesn't say that they're charging, but you do need to know that this is our charging capacitor. All right, this exponential function, actually, you can think about this because this exponential function, this goes to 0, this e to the minus t over RC. So this function will look like this. Will approach some maximum value Q. And that's what's happening when you're charging. So this function is only for a charging capacitor. This is for a discharging capacitor. Okay? Go back and look at those notes and just sort of make sure you're aware of what's here. This is what you'll have on the test. And make sure you're aware of what is regarding capacitors charging and discharging. All right, so now my Q is equal to C times V, 1 minus e to the minus t over RC. Remember, this is just hearkening back to chapter 4 when we did capacitors. C times V is 5 times 30. That's 150 microcoulombs times 1 minus e to the minus t, which is 10 seconds, over RC. RC is the resistance times the capacitance. The mega and the micro cancel out, so I'll just not worry about those. That'll be the case for you too. So it's divided by 5 seconds. My time constant, this is my time constant, tau equal RC. All right, and then you would calculate what that is. I don't know what it is right off. If somebody could find that for me, I'd appreciate it. In order to become fully charged, V, that's 10 times tau. That's going to be 10 times 5, which is 50 seconds. Whatever your time constant is, multiply it times 10. And then the charge on the capacitor varies with time. This is charging. So charge versus time. I'll be looking for a sketch. I want to see that. I also want you to show me that this is that maximum charge Q. Anybody get this value up here? 130, that sounds about right. All right, make sure you can do that exponential thing on your calculator. Sometimes you have an E button. It's not the EE button. It's it's connected usually with the natural log on your calculator. Okay, probably gonna see one of those. We're gonna do a lot more resistors or capacitors later, so RC circuits later. So you might see that. I'm not guaranteeing it, but you might. Okay, folks, 7:15 on Wednesday. I'll pass out the exam. And I'll see y'all then. I'll be around, so come see me if you need help with it. Have a great day.